Hello, I'm Rob Winchcombe. I'm here at Propeller in Belize with PwC Customer Manager Francis Moreau. We'll be showing you how to use the Aircraft Maintenance Manual and the Engine Maintenance Manual to rig each aircraft and engine the same way.
This video will show you how to rig the Grand Caravan EX powered by the PT6A140 engine. Rigging a single engine aircraft is less complex than a twin. Let's go inside, take a look at the engine controls. The Grand Caravan EX has 4 levers to control the engine. This is the power lever, or PLA. This is the propeller lever. This one is the fuel condition lever. And finally, this is the emergency power lever, or EPL, and sometimes called the manual override. First, let's take a look at the propeller control system. Make sure that the lever on the governor is always indexed to the same angle at the feather position. Check to see that both stops are contacted when the propeller lever in the cockpit is moved from the feather position to the maximum position. Now let's rig the power lever, starting at the front section of the engine with the propeller beta nuts, feedback ring, beta lever, and finally the propeller governor reset link. With the spinner removed, check that the torque paint on all the beta nuts is intact. This is a factory setting on this Macaulay propeller and the beta nuts are not field adjustable. Confirm that there is zero run out of the feedback ring forward interface. There need to be no run out to avoid the beta valve cycling every revolution of the propeller. Use visual guides as reference for this check. Before we rig the beta lever, we need to disconnect the rear Clevis at the Cambox. Check the beta lever and carbon block for damage and correct dimension with the feedback ring. Install the beta lever with the carbon block retention pin head facing up. Make sure that the end of the beta lever goes under the guide pin when you install it. The beta lever center pin can now be inserted and the connection at the beta cable made. Using the low pitch stop adjuster, set the beta valve in the flush position. Per the aircraft maintenance manual for this aircraft, the flush position is with the bottom of the Clevis, flush with the beta valve end cap. Here is the flush position. Pull the reset link forward and adjust the rod end to be a sliding fit with the beta cable bolt. Then shorten the rod end half turn to add preload. A piece of paper can be inserted at the reset arm stop and should be held firmly once the reset link is installed. Now that we've rigged the forward section of the propeller lever, let's go to the rear of the engine. The rear section connections for the power lever are the Cambox connection and the fuel control input lever. This is where the Cambox input lever is installed, the cam track point is established, the cockpit lever connection made, the upper interconnect rod is connected to the actuating lever, the FCU input lever and interconnect rod connected at the FCU, and finally, the rear beta cable connection is made at the cam. The first connection is to install the Cambox input lever. This must be done with the actuating lever rotated fully counterclockwise. The input lever is installed at the 6 o'clock position, then it is indexed 2 serration clockwise and secured. The track point. Move the Cambox input lever forward into the middle of the cam lobe. Gently push the propeller reversing cam forward. Slowly move the input lever rearwards until the propeller reversing cam is contacted and about to move. This is the track point. With the power lever at the idle gate, with friction lock applied, the connection with the Cambox input lever is made as a sliding fit and secured. Check that the rod length is 8.25 inches between centers. Adjust if required. Install the interconnect rod in the third hole from the top of the actuating lever and secure. Before making the connection at the FCU, place a piece of tape along the quadrant next to the power lever. With the PLA still at the idle gate, place a mark across the tape at the rear of the power lever as shown. Measure 1 inch behind the mark and draw another line. This is about where the rear NG pickup should be. Finally, make a mark 0.15 inch forward of the idle gate. Place the power lever at this point and apply the friction lock. The FCU connection can now be made. With the deadband screw touching the cam surface, install the serrated washer and FCU input lever at a position approximately where the lower end of the interconnect rod can be connected to the outer hole of the FCU input lever. At this point, the alignment does not need to be perfect. Some fine adjustment of the serrated washer will now be required, so use a Sharpie to mark a reference line across the assembly as shown. We can see that there is a slight misalignment between the rod end and the lever, so a sliding fit is not possible. The FCU input lever needs to move forward slightly, and this is achieved by turning just the serrated washer forward, or clockwise, several serrations. Each serration indexes the FCU input lever 0.6 degrees. With the deadband screw touching the cam surface, the bolt can be inserted easily. This is a sliding fit. With the connection now made, move the power lever fully forward to make sure the forward NG stop on the FCU is contacted, then to full reverse to make sure that the reversed NG stop on the FCU is contacted as well. Move the power lever fully forward and insert a piece of paper as shown. Pull the power lever to the idle gate, then move it slowly forward until the paper just releases. This should be at the same position as the forward mark on the tape. Reinstall the paper and bring the power lever back to the idle gate. Lift the power lever through the gate and slowly move it towards reverse. Stop moving the power lever as soon as the paper releases. The power lever rear edge should be close to the rear mark, about 1 inch behind the gate. Let's look at what you might get. Pause the video if required. The forward pickup point should be correct, as this was the original set point. The reverse pickup point may be significantly different. In this example, the rear pickup point is too far back and the deadband too wide. We reduce the size of the deadband by turning the deadband screw out. This reduces both the forward and reverse pickup points as shown. The paper check should be redone to show these new pickup points. After adjusting the deadband screw, the serrated washer is used to re-establish the forward pickup point. In example 2, we need to turn the serrated washer clockwise to move the whole deadband forward. To move the deadband forward, adjust the serrated washer clockwise several serrations. To move it rearward, adjust the serrated washer counterclockwise. Adjusting the deadband screw will also change the low and high idle NG speeds. Make sure to check these during the engine run. The final step is to connect the beta cable rear clevis to the reversing cam. Install the beta rear clevis in the middle hole of the propeller reversing cam as a sliding fit, then lengthen the clevis by half a turn and connect. Condition lever rigging. Place the cockpit condition lever at the low idle position and apply the friction lock. Position the condition lever so that a 3/16" drill bit can be inserted. This holds the condition lever at the low idle position. Adjust the rod end to be a sliding fit with the middle hole of the condition lever. Insert the bolt and secure. Remove the drill bit and cycle the condition lever between high idle and cutoff, ensuring that both stops on the FCU are contacted. The emergency power lever. Rigging the emergency power lever is performed with the lever at the normal position in accordance with the airframe maintenance manual. As the name implies, the emergency power lever is intended to be used in emergency situation only. It must never be used for engine troubleshooting. Now that we've done the basic rigging on this engine, let's push this aircraft in the run bay to do the final adjustment. The goal is 3 runs and you're done. With the aircraft in the run bay, we can now complete the rigging and make the final engine adjustments. If the rigging has been set up correctly in the hangar, the only check to be done in the run bay is the max reverse torque check. But we will take the opportunity to show you some of the other engine adjustments which are important for consistent engine operation. These are low and high idle NG settings, max propeller speed and max torque, the torque limiter function check, propeller maximum speed for reverse operation, the minimum governing propeller speed and feathering point. With the engine at low idle, slowly select reverse with the power lever. Propeller speed should initially increase as the power lever is moved towards reverse and NG should remain constant. As more reverse is applied, the propeller speed should drop 10 to 50 RPM before NG begins to increase. However, what we really need is that the minimum reverse torque of 900 foot-pound is achieved. On this test, we are limited at about 760 foot-pound torque and no propeller droop occurred. We need to increase max torque in reverse and obtain the propeller droop specified. To achieve these two requirements, we will first increase the max reverse NG speed stop by turning the screw in or clockwise. This will also provide more reverse blade angle. Recheck that the FCU maximum reverse stop is contacted when the power lever is moved to full reverse. Now, we will increase the deadband by turning the deadband screw in or clockwise as shown. This will allow more reverse blade angle before NG pickup occurs, but it also changes both pickup points. To bring the forward pickup point back to its original position, the deadband needs to be moved rearward by indexing the serrated washer several serrations backward or counterclockwise. Before running the engine, make sure that the rear beta cable Clevis is reconnected. Run the engine and slowly move the power lever to full reverse. Confirm that the propeller speed now droops before pickup occurs and that the minimum torque requirement at full reverse is now achieved. If the reverse torque requirement is still not met, a further turn on the max reverse NG stop screw should be tried. Recheck that the max reverse stop is still contacted. We can also see that we are achieving more than the minimum torque required. If the reverse torque requirement is still not met, a further turn on the max reverse NG stop screw should be tried. Now, we've finished the rigging of the engine. Let's do some engine adjustments. Let's look at low and high idle NG. With the normal loads applied and engine oil temperature in the normal range, check that the NG meets the airframe maintenance manual requirement. The high idle check is similar to the low idle check. Simply move the condition lever to the high idle position and check that NG meets the airframe maintenance manual requirement. Here's how to adjust the idle speeds. To adjust low idle, first loosen the clamping screw. To increase idle speed, loosen the right end screw and tighten the left end screw against the tank. To decrease idle speed, loosen the left end screw and tighten the right end screw against the tank. This is a very sensitive adjustment. Finally, tighten the clamping screw and secure all screws. Adjusting the idle NG speed is done by loosening one nut and tightening the other. Moving the roller towards the cam increases the idle speed. Moving it away from the cam decreases idle speed. Do this adjustment only after adjusting the low idle speed. The maximum propeller speed and max torque check. For this check, ensure that the aircraft is fully secured. With the engine oil at normal operating temperature and propeller lever fully forward, slowly move the power lever forward until the maximum takeoff power is reached. Record the propeller speed achieved. Adjusting maximum propeller speed. Adjust the screw in to reduce speed or out to increase speed. Typically, propeller speed will increase a little during the takeoff roll. Be aware of this effect when setting the maximum speed. Be careful not to adjust the feather stop instead of the max stop. The torque limiter function check. When doing this check, ensure that the aircraft is fully secured. With the engine oil at normal operating temperature and propeller lever fully forward, slowly move the power lever forward until NG, fuel flow and torque stop increasing. Continue moving the power lever forward. The engine parameters should not increase. The engine is now limited by the torque limiter. If the set point of the limiter needs to be adjusted, refer to the instruction in the engine maintenance manual. Maximum propeller speed in reverse. To do this check, the reset link on the propeller governor is disconnected and the reset lever is secured to the engine lifting bracket on the A flange. Push the propeller lever to the forward stop. Advance the power lever forward until all engine parameters stop increasing and note the propeller speed. The engine maintenance manual defines the target propeller speed for this setting. The power lever can be pushed further forward with no change in propeller speed, NG, ITT, fuel flow or torque. The propeller governor is now bleeding PY in order to prevent further engine response. Here's how to adjust the maximum reverse propeller speed. The maximum propeller speed in reverse adjustment has a reference mark on the lock plate and a dimple on the adjustment screw. Loosen the two lock plate screws, then turn the adjustment screw away from the reference mark to reduce the maximum propeller speed in reverse. Turn the adjustment screw towards the reference mark to increase the maximum propeller speed in reverse. One blade width is approximately 50 RPM. Minimum governing propeller speed and feathering point. Slowly pull the lever through the gate and watch the propeller speed. The lever should be well through the gate before the propeller feathers. This test demonstrates that the propeller will not inadvertently feather when the lever is pulled quickly back to the gate. Pull the propeller lever from maximum to minimum governing speed gate. Check that the propeller is not feathering and note the speed.
By following the simple procedures per the aircraft engine maintenance manual, each aircraft will handle the same way.
Finally, we would like to thank Propeller and all the employees who made this video possible. The last few days have been a lot of fun for us. Thank you guys.
Thank you.